Okay, everybody, Miss Gray and Jeter here helping you with your slope and rate of change test review. So I'm going to walk you through our test review and how I went about solving these problems. Of course, Jeter is here to help. So remember, slope and rate of change, they mean the same exact thing. So if you see a question, it's asking for the rate of change. All it's asking is what is the slope. So let's take a look at number one. The number one is what I call a real world example or application. So here we have a gorilla's weight in pounds represented by the function f of m equals 15 plus 16m, where m represents the time in months. They're asking what is the rate of change. So keyword there, rate of change, they're just asking for slope. So one thing I'm going to remember is to find slope, we always want to be in slope-intercept form. Okay, so that is y equals that mx plus b. Now look at this equation here and ask yourself, is this in slope-intercept form? It is. Do not let that letter m throw you off. It's still in slope-intercept form. Okay, this here is our b, this is our m, and this is our x value. So here I have a slope or a rate of change of 16. So I already know anything with a 15 in it is not correct. So I'm going to get rid of A and I'm going to get rid of C. I'm going further in my problem and I see that M represents the time in months. So that is 16 per month. Well, there's my answer, 16 pounds per month. So let's take a look at number two. So we're asking which equation shows the same slope as the points in the table. Here I'm going to use my slope formula. Remember, you do not need to memorize the slope formula. It is on your star chart, which you will have every test you take, including your end of course exam, which is your algebra star. So our slope formula is our m equals our y2 minus y1 over x2 minus x1. So the first thing I need to do is I need to choose 2 points. It does not matter which points I use. I'm going to start with, I think I'm going to use this point here, and I'll use this point. Only so I don't have to deal with a negative and I don't have to deal with a decimal. But you could have used any combination of any points, okay? Once I have my points, I'm now going to label my point. I'm going to label this as my x1 and my y1, my x2 and my y2. And now that my points are labeled, I'm simply going to plug them into my formula. So my y2, well, that's my 4, minus my y1, that's my 2, over my x2, that's my 8, minus my x1, that's my 0. And now I'm going to simplify. 4 minus 2 is 2. 8 minus 0 is 8. So I have 2 eighths. If I put that into Desmos, it simplifies to 1/4, which is the same as if I put it as a decimal as 0.25. Now looking at my equations, the only equation, because remember our equations are written as y equals mx plus b, so I need to look at that m. So what is attached to the m? Anything with 1/4 or 0.25, that is d. I do not care what my y-intercepts are. I am just simply looking at my slope. Let's take a look at number 3. And number 3 is what is the rate of change? So they're asking for slope. And this is from a graph. One thing I'm going to remind you when looking at graphs is please look at the scale it's written as. So for example, on my x, all of these are in a scale of 2. I never want you to get into the habit thinking that each hash mark on either the x-axis or the y is always going to equal 1. So please make sure you are looking at the scale. So here my x's are increasing by 2 and my y's are increasing by 6. So that's going to be important here. Okay? So in order to find a in order to find a rate of change, I need 2 exact points. Okay, so I'm going to choose 2 exact points. I always will start with my origin here. Okay, that's a good point. And the other point that I want to use is I want to use a point that goes exactly on a grid line. It doesn't meet halfway. So I'm going to use my point 4, 18. Okay, I do not want to use, let's say for example, I do not want to use a point here. And the reason why is because I really don't know what the y value of that is or the x value is. I'm making an estimate, and we can't make an estimate when we're talking about slope. So now that I have my 2 exact points, I am going to draw my slope triangle. And for slope, it is just what is our change of y over our change of x. So step back and take a look at your graph. First, notice what type of slope is it? Is it a positive slope, a negative slope, a 0 slope, or undefined? We should see it's a positive slope. Any answer you choose needs to have a positive. So if any of these answers have a negative, you know that that is incorrect. So let's see, they're all positive. Okay. So now I'm going to plug it in, my change of y over my change of x. So let's start with my change of y. I went from 6 to 18. So counting by 6, there's 6, 6. I increased by 12. I went up 12. Okay. And then on my x, I went from a 0 to a 4. So I went over 4. So if I reduce this 12 over 4, that leaves me with 3. And that is my slope. Each pass was $3. Now I could have also done this instead of using my slope triangle. I could have written the ordered pairs. So still choose 2 points. Here's my first point of my 0, 6. My second point of my 4, 18. And just like we did with our table, I can label both points x1, y1, x2, y2, and plug them into my slope formula. So here's my y2 minus my y1 over my x2 minus my x1. It would have left me with 12 over 4, which would have reduced to 3. Both strategies will get you the same exact answer. Use the one that works best for you. Looking at number 4 here, we're asking for a slope, and it gives me points. Okay, I'm going to use the slope formula. So the first, I'm going to identify x1, y1, x2, y2. And now I'm going to plug them into my slope formula. I look at my star chart. My slope formula is y2 minus y1 over x2 minus x1. And I'm simply going to plug them in. My y2 is negative 6 minus, because that's part of the formula, my y1 is 7 over my x2 is positive 2 minus my x1 is negative 3. And this is where I am going to put in those parentheses. We talk about that in class because those parentheses allow me to capture that negative because I don't want to lose either of these negatives here. And now I'm going to simplify. I'll put this into Desmos. Negative 6 minus 7 gives me negative 13. And 2 minus negative 3. So these two negatives together turn into a positive. So I'm left with 2 plus 3. I have negative 13 over 5. And that is my slope. Okay, looking at number 5, slope from a table again. So same strategy, I'm going to use my slope formula. I'm going to take 2 points and plug them in. So I'll just start with the top 2. Here is my x1, my y1, my x2, my y2, and now I'm going to plug them into my slope formula, which is that y2, y1 over x2 minus x1. So my y2 is negative 2 minus my y1 is negative 4 all over my x2, which is negative 1, minus my x1, which is negative 5. This one, I highly encourage you, whenever you're dealing with multiple negatives like this one, always use your parentheses to capture it. So here I have this double negative, so this becomes a positive. So I'm left with negative 2 plus 4, that gives me positive 2. Same thing, double negative gives me a positive. I have negative 1 plus 5 gives me a positive 4. And here I'm going to reduce 2 over 4 gives me a positive 1/2. Okay. Number 6, we're back to an application. So Emily jogs around a 400-meter track. She uses the linear equation, y equals 400 plus 3x. I'm hoping you've already picked up that this is y equals mx plus b. They just flipped the order of the slope and the y-intercept. Remember, slope is always attached to the x variable. So which one of the following best describes the rate of change? I'm hoping you recognize that rate of change is here attached to the x, so that is r3. And she's jogging 3 meters in 1 second. No solving involved. You just have to learn to identify where she is in the equation. So number 7, okay, talking about Allison now doing some push-ups over several days. On the 3rd day, she completed 315 push-ups. Wow, that's a lot. And on the 8th day, 510. I'm going to first say that Allison must be pretty strong. So what is the slope? Well, believe it or not, we have 2 points. We have an x and we have a y. Okay. Remember, our input is our days and our output is the push-ups. So our first point is here. On the 3rd day, she completed 315 push-ups. So on the 3rd day, she completed 315 push-ups. That's our first point. On the 8th day, she completed 510 push-ups. That's our second point. And now I'm going to put those into my slope formula. I'm going to label them and then plug them in. So I have 510 minus 315 over 8 minus 3. So let's see, I'll do the math. 510 minus 315 is 195. 8 minus 3 is 5. And then I'm going to simplify. 195 divided by 5 is 39. So that is the slope, or that's the rate that she's doing push-ups. So she's doing 39 push-ups each day. Good for you, Allison. Keep it up. Let's look at number 8. Okay, so let's look at problem number 8. We have Rhonda with some music. So she's downloading 12 songs and pays $15.67. The next month she downloads 15 and pays $18.34. And what rate? So just like number 7, we have 2 points. We have 12 and $15.67. And then we have 15 and $18.34. Okay. And I know these are points because I can say 12 songs, she pays $15.67. My input is songs. My output is the cost. Okay, that's my Y. And then I'm going to label my 2 points and plug them into my slope formula. So Y2 minus y1 over x2 minus x1. And then I'm going to simplify this, and I'm going to plug this into Desmos. 1834 minus 1567, that gives me 267, 15 over 12 over 3. So I can see that's my slope right there. And if I wanted to know the cost per song, I could simplify that one step further. 267 over 3, that would be about 89 cents per song, but it only asked for this one here. So we're going to leave it. Okay. Let's take a look at number 9. I'm highly going to encourage you at this point to try this one on your own. So stop the video and see what you can do with it. So after reading this scenario, you should know you have 2 points. Hopefully you found your 2 points. You have your 10 and 40. And at 40 seconds, she has 100 meters. So 1 point, I have 10 and 40. Second point, I have 40 and 100. And now I'll plug them into my formula. Okay, I'm going to label them again, x1, y1, x2, y2, and plug it in. 100 minus 40, and 40 minus 10, so I'm left with 60 over 30, which is 2, and D is my answer. And last, let's take a look at number 10. So we're back to slope from a graph. Okay. The first thing I'm going to encourage you is when you look at graphs, always look at look at the scale. Okay, my x there by scales of 1 and my y scales of 1. Okay, and then I'm going to encourage you to first identify what type of slope is it. Is it positive, negative, 0, or undefined? Well, looking at this one, it is decreasing from left to right, so I already know I have a negative slope. Look at your answer choices. Are there any answer choices you can eliminate? Well, yeah, I know I'm going to eliminate C and D because they're positive choices. So already I know A and B are the only 2 options. And then from here, I'm going to choose my 2 points. I'm going to choose my y-intercept and I'll choose my x-intercept. And I can draw my slope triangle. And then I could either do this by points. My y-intercept is 0, 4. My x-intercept is 6, 0. And I can plug this into my slope formula. Or I can do this by my change of y over my change of x. So my y, I went down 4. My x, I went over 6. And if I reduce that, negative 4, 6 reduced to negative 2 over 3. And A is my answer.